Struggling to interpret complex hysteresis loops? Let's break down exactly what these plots are telling you.
This chart shows the moment-frame connection, typical sample response profile, plotting moment versus rotation for test specimen number 1. Here we introduce the data for test specimen number 2, comparing its moment versus rotation profile with test specimen number 1. This view expands the scale on the x-axis, rotation, to better encompass the full range of both test specimens' responses. We overlay the maximum response envelope for both test specimen number 1 and number 2 on the moment versus rotation graph.
We now look at the peak positive moment, plus M peak, which represents the maximum positive moment resistance observed in the test. This value is identified for behavioral characterization only, not as a design strength, because it helps distinguish whether the connection fails abruptly or exhibits stable, gradual post-peak ductile deformation. Next, we identify the slip or pinching region, which corresponds to the clearance take-up and pre-bearing engagement in the connection. This area highlights the bearing engagement or the transition to a bearing-controlled stiffness within the moment frame connection. The lines indicate the positive and negative stiffnesses observed in the response profile, representing the rate of change of moment with respect to rotation. We point out the occurrences of strength degradation in both the positive and negative directions of the moment versus rotation profile. The graph shows the rotational limits for the onset of strength degradation, noted as positive theta SD and negative theta SD. The marked points indicate the system yield point, which signifies the onset of stiffness degradation, identified at positive and negative moments. The green lines represent the OMF minimum design boundary line, illustrating the margin of safety relative to the strength degradation rotation limits. This scene highlights the IMF minimum design boundary lines, showing the margin of safety for intermediate moment frames. Finally, we display the SMF minimum design boundary lines, demonstrating the margin of safety criteria for special moment frames.
To wrap up, the area inside the hysteresis loop tells you how much energy is dissipated, while the shape and slope reveal your material's stiffness and deformation behavior.
That's the fundamentals of reading hysteresis plots. The loop isn't just a curve, it's a story about your material's performance. If this helped, drop a comment. Thanks for watching.